Email, Twitter, take it down, send me questions, anything about Spring, I'm happy to help. Happy to point you in the right direction, anything I can do. Nice to meet you. If you have questions, by the way, any of them at all, like, please ask me as we go along. Books. I've written 4 of them, all about Spring. My 5th one is about Cloud Foundry in Spring, which is coming out from Manning. These are 2 of them. The one on the right there, the Getting Started with Rue from O'Reilly. It is available for free. So springsource.org/Rue, and there's a link. You can download the book. Okay. So, again, this is not you guys. I'm very lazy. Really lazy. And I've always built applications thinking I want to do as little as possible. The application was what mattered the most, you know? So I take my typical example. I want to create a service, some sort of object that has a contract. So I add a little @service annotation to my object. This method will handle creating customer records, right? Very simple thing. We've all done this 1,000 times. I'm going to need Hibernate 4, so I go ahead and inject my session factory. We'll not bother with a configuration for that. You know, it's going to be in some Spring configuration. But you need a session factory. You inject it, and then you create a customer, an object, and then you get the session factory and get the session, and then you save it. No big deal. We've all done this 1,000 times. You want transaction management. After all, you don't want to be able to store data and not guarantee that it's being persisted. So you annotate the method with @transactional. Then the data is transactional. So all operations in the method are wrapped in a transaction so that they all commit or they all fail. Again, we've all done this before. I also want to cache the results. So when somebody calls that method, if they call the method 10 times with the same arguments, I want the result to be stored. I just want to look in the cache, go to EH cache or whatever, or Redis, you know, some other technology. And then finally, I'm going to probably want some sort of RESTful endpoint, some way of interfacing with this service quickly from my JavaScript and from my rich clients, my mobile clients, and so on. So I'll use Spring MVC 3.0 and better, and I'll add a little @controller to my controller class. I'll inject a reference to my service object, and then have a method there, right? So it's customer by ID using the Spring MVC REST annotations. And then whenever somebody goes to that URL, this method gets called, and I get my customer object, and it gets converted into JSON or XML. And that's pretty much it, right? I mean, we've already got a pretty interesting application kind of quickly. There's no arguing that Spring itself is very powerful, and Spring on the bottom, I mean, if you have the Spring component model at the bottom, then you have all these great technologies on top of it, like Spring Integration, Spring Batch, Spring MVC, Spring Data, which does NoSQL and so on, that let you talk to the components that are sitting in the Spring framework. And then when you build your application on top of the Spring framework, you are now free to move your application from one platform to another, right? That's one of the things that Spring is very famous for is, you know, you can take your application written on, something really slow and horrible like WebSphere or something like that, and move it to something lighter and more agile like Tomcat. And of course, these days we're also talking about the cloud. Cloud's a big part of the story, right? Increasingly, you need a choice. You need to think about the platform onto which your applications are deployed. So we need a platform, and we have different concerns than we did last year. You know, even the year before. Scale is a big part of it, right? Elasticity is a big part of it. A lot of people are moving to the cloud for these reasons. My particular favorite choice, just me, you don't have to, take my word for it, but my favorite choice is Cloud Foundry. It's an open source platform as a service from VMware. When you talk about Cloud Foundry, you talk about 3 different things, yeah? You have at the top, you have the environments, then you have the different types of runtimes and technologies that are supported, including Java and Spring, and Grails, and Rue, and Scala, and Ruby, and Node.js, and others that I'm forgetting. And then you have the different types of infrastructure services. You have your standard RDBMSs like Postgres and MySQL, but you also have a message queue like RabbitMQ, and you have NoSQL data stores like MongoDB and Redis for caching. So lots of options, right? Out of the box, Cloud Foundry supports, like I said, it supports Java, it supports Scala, it supports Ruby, It supports Node.js. We also have other people in the community who have taken the code for Cloud Foundry, and then they have built their own support on top of it. Because, again, Cloud Foundry is open source, github.com/Cloud Foundry. So you have .NET support. You have Python. We even have that other one with a P. How many of you guys know somebody who once knew somebody who tripped and fell and hit somebody else who knew PHP at some point? Anybody? They're out there. There's PHP people out there. You can't hide from them. They're everywhere. And they need a cloud too, right? So here's one of them. There's Haskell. There's Erlang. I'm not suggesting that you guys are all going to go home and program in Erlang, but if you were, there's a cloud for you as well, right? So all built on top of Cloud Foundry. In Cloud Foundry, getting to the specifics now, getting to the nitty-gritty, the goal is to make it very easy to deploy applications quickly, right? And you need to be able to say, hey, I need Redis. I need a Postgres instance. I need MongoDB. And I want my application to run, right? You are saying that I have an application and I don't want to worry about setting up all this infrastructure. I don't want to have to do sudo apt-get install and all those things to configure. I just want it to work. I want to move quickly. In Cloud Foundry, we provide this idea of a manifest. This manifest is something you deploy at the root of your application. So if you're using a Ruby on Rails application or a Spring application, this still lives at the root of the WAR, at the root of the Ruby on Rails application, at the root of the PHP the application, etc., right? And you can express which kind of services you need. So pretty declarative, right? This is actually saying, this is how my application needs to be treated at runtime. This is the stuff that you just wish you could give this to your data center guy, your operations guy right now, and have him translate that in something meaningful, right? Well, now you can. This is like a ticket with the operations people. The one that takes 6 months to fill, well, this just takes a couple seconds. So we've established the big pictures. Let's dive into it. Was a question?
Why was memory twice there in
previously? Memory for the server versus memory for the framework. In this case, I'm saying I want 512 for Java. You don't always have to do that. I'm just doing it here. Hold on, though. OK. Let's actually take a look at it, though. So first things first. I'm going back into Springsource tool suite. We're all, how many of you are using Java? Spring? OK. Eclipse? Groovy? Right? I'm in the right place. Good stuff. This is the Springsource tool suite. It's an Eclipse distribution that you can get from Springsource. So springsource.org/developer/STS. Download it for free. Even if you're using Eclipse and you just want a very convenient Eclipse distribution that has all the stuff that is painful to install, this is a good choice. I'm also, before I get into Eclipse though, I'm going to deploy a little application here. Close this here. I've got this guy here. Can you guys see that? Probably not. Yeah? Yeah, groovy. So go to this guy here. So this is a simple Spring application. I'm going to clean and install. While that's building, this code, you guys can get it from here. You can go to Cloud Foundry Spring MVC template from github.com/Josh Long. And I have a failure. You know why I have a failure, guys? Because I'm connecting to a local database, which isn't actually running at the moment. This is important, so, there you go. It's running. We go back to my code, compile the bugger. Come on, unit tests. I know, people think I don't unit test, but I do. It's a little courtesy I do as a professional. So anyway, I have my application. I want to get started. The easiest way to get this application, forget about Eclipse for now, forget about Java, let's just talk about you and me and the cloud. The way to do that is to use the VMC tool, right? So VMC, and this tool is like the subversion command or like the git command. It points to whatever server you want, right? So it can go to server over here, server over there. It's not like you have a subversion command that only knows about your source code repository, right? You wouldn't use something like that. It would be too limited. Well, VMC works with as many different Cloud Foundry instances as you want because it can run anywhere. So first thing you have to do is specify which one you want to work with. So you say VMC target API.cloudfoundry.com. Cloudfoundry.com is one environment, right? This is why I needed Wi-Fi, because I'm going to ping one environment. It's taking a while. So the good news here is I come prepared. So instead, I'm going to target my little virtual machine here, which is running locally. Let's see, good. So I've got a virtual machine here. This is called the Micro Cloud Foundry. It's a fully working virtual machine containing Cloud Foundry, everything you need to be able to deploy and test and iterate against Cloud Foundry. So this virtual machine is running inside of VMware Player. I've heard, but cannot confirm, that it runs in those other VMware virtualization technologies like VirtualBox. But anyway, this is free on Linux and Windows anyway, so hopefully you'll be able to get access to it. And we'll look at the microcloud in a minute, but the point is it's a fully working Cloud Foundry. So I don't need to be online, right? So now I'm going to do VMC target api.joshlong.micro. And that's going to resolve to that virtual machine running locally, right? I have defeated the terrible Wi-Fi here. So now I can do VMC apps, and there's nothing deployed. I have nothing running, which is a shame. But we'll fix that, right? So VMC, before I do that, I'm going to go into my, I'm going to do this. I'm going to RMF that, and then I'm going to Maven clean install. I don't want the manifest here. I want you guys to see what this looks like without the manifest. Okay. I'm going to do VMC push, VMC path target, and I'm going to select the directory containing my application. Then I'm going to do VMC push, right? It's going to ask me the name. What do I want to name my application? I'm going to choose Spring MVC, whoops, not Spring at GIDS. Spring MVC at GIDS. And that's the URL. So it's going to say, do you want to use that URL? I'm going to say, sure. Why the heck not? It's going to ask, is this a Java application, a Spring application in particular? It detected that. I'm going to say no, just because I want you guys to see the options. So if it will detect very, very correctly. It'll detect a whole lot of different types of applications. Here I've got Rails and Spring and Grails and Lift and basic Java web applications and what have you. Just to show that it's all the same, I'm going to choose Java Web. I'm going to choose 5, right? Because Spring web applications are Java web applications. And it's going to ask me how much memory I want. It's going to give me a default of 512 megs of RAM. Sure. How many instances? 1 for now. Now, here's where it gets interesting. It's going to ask me, do you have anything you want to connect to? Do you have a database you need to use? Do you have any kind of services that you need? And I do, actually. I know that this application needs a database. I also know that it needs a cache, someplace to cache the data. So I'm going to hit yes, absolutely. I want to create some services. First things first, I need a Postgres instance, because Postgres is awesome. Good stuff. I'm going to just let it choose the default name. I don't care. Create another, yes. I'm going to choose Redis, number 5. Leave the name there again, choose it, and then I'm going to say no, I'm done. So I'm not going to create another. Would I like to save this configuration? Yes, because this is an interview. It's a very boring interview. It's a lot of questions you don't want to have to answer each time you're deploying an application. So I'm going to hit save, and it's going to write out that manifest file that I just deleted before. Right? If I had left the manifest file there in place, it would have just skipped all of this stuff and it would have deployed it for me. So we saw the manifest file before, and now you see how to write those manifest files. It's very easy. You just follow the interview process and do it once, and then you're done. And so now I can do VMC apps, and I can see, okay, well, my application is deployed at this URL, and it's got a Postgres instance, and it's got a Redis instance. So let's look at my simple Spring MVC application. Oops. Go there. So now we see, I go to, customer, 1, whatever. Or not. Oh. So nothing there, right? No data. I go into here, I say I want all the data. I want all the customer entry. This is just REST. This is just regular JSON data. And you can see I've got nothing in my database, right? Nothing up my sleeves, nothing working. Makes me sad. That's easy. So the next question is, well, how do I get into my database and start playing with it, right? I can do VMC tunnel. Actually, I can do VMC services. And you can see which services I can create, and you can see which services are already created. So I have a Postgres instance and a Redis instance. I know that I need to get access to that Postgres instance to be able to put data in there, right? So VMC tunnel, this guy. And what it's going to do is it's going to punch a hole in the cloud for me. So the cloud is what's managing my application and my data services. It's not going to give me the host and port and all that stuff that I need to connect to those services. That's up to the cloud to manage, and it may change. So what it will do is it'll punch a hole into the cloud for me so that I can run tools locally. This will make it very easy for your data center people, the operations people, you know? Because as much as you and I would like to pretend that getting Redis and getting Postgres all set up is all you need, it's not. Those poor bastards have to carry a beeper and go home, and they have to sleep with that thing. And if something goes wrong, they get in trouble, you know? So you have to give them the ability to do backup scripts and to do basic things like that. So this is how you do that. It's a tunnel. So I'm going to say, it's going to ask me now, hey, you've punched a hole into your cloud. Do you want to start a client to work with it, right? Just like you would if you were using a command line tool locally. It even gives me a couple choices. In this case, I'm going to choose pSQL, which is the command line tool for Postgres. And voila. So I'm in my, database schema. I can actually take a look around. You can see in here, select all from customer. You know, first of all, you can see that I can't type. And then you can see there's nothing in there. So we'll fix that right now. I'm going to open up my code here. Mate. And we want some SQL statements. It's a good thing that I keep this really, really deep in the code. Makes for interesting reading. Okay, so again, first rule of demos, always keep a backup. I need data. We knew that I needed data. Oops. So there's my SQL statements. You guys can follow along at home. So there you go. So now I go back to my application, and I ask it for all the customer data, and it gives me the JSON representation of all the customer data that I've put in there. This is a Spring application. We'll look at the Spring application itself. But you can see the full gamut of deployment and provisioning your services and getting everything working is in place already, right? No big deal at all. And it's a Spring MVC application, works just fine. Not a very big Spring MVC application. You can see it's, a few classes basically. But it is a Spring MVC application. Now, I don't know about you guys, but that command line thing is not my way to go, right? I wouldn't, the command line works fine, but I need an IDE. I need to work in my comfort zone. I need to be at home in my Eclipse. So Eclipse, this is, again, Springsource tool suite. Let's import that same project. I'm going to go to File, Import, Existing Maven Projects, hit Browse, and then it's going to ask me which code I'd like to import. I'm going to say go to the greatest conference ever, and then I'm going to choose this guy. And this is the application that we're deploying before, right? It's going to import it. It's just a standard Maven project, nothing special here, but give me a second. Of course, it would choose today to synchronize the dependencies and everything. Come on, you can do this. That is so awkward. Come on, Wi-Fi. Come on, internet. There we go. Hit finish. So the cloud has defeated Wi-Fi, but Maven still not so much. So okay, so now I've got my little application. Again, Spring application, no big deal. I want to deploy it and work with it just like I would any other application. If you guys were using Eclipse, you would define a server, right? Just like an Apache Tomcat or something like that. Well, if you're using the Springsource tool suite, you can go to the dashboard here, and you can go to extensions. And if the Wi-Fi were working, you'd see a whole bunch of extensions, and you could actually search for Cloud Foundry, right? And that provides you support. I've already installed it, so I'm not gonna. I'm going to create a new server called Cloud Foundry, imaginatively enough. And I'm going to specify that I want to talk to my micro cloud. I'm not talking to cloudfoundry.com, the hosted version, right? So I'm going to click on Manage Cloud. I'm going to choose api.joshlong.micro because I set this up before, but I can, so you guys can see, you could add, and I'm going to say micro cloud foundry api.joshlong.micro HTTP. It's always going to be api.whatever, whatever. Hit OK. and then choose it, right? So api.joshlong.micro. I'm going to log in. My credentials, don't tell anybody, but I mean just between friends, but it's cowbell. Cowbell. So okay, hit validate. You can see that my information is valid. I'm actually able to log in, right? You can do the same thing from the command line. You do VMC login so that if you move from one cloud to another, you have a way of saying I'm authorized to make changes, obviously. Hit next. I'm going to choose not to deploy anything yet. I'm going to hit finish. It's going to churn for a second. And now, if I double click on this guy, you can see I've got a lot of the same information that I have from the command line tool. Right? I clicked on the applications tab down here on the bottom. I can see my Spring Mvc GIDS application deployed in the cloud. I can administer it. I can actually update. I can see how much RAM is being taken and the CPU and all that stuff. I can update the RAM itself. I can deploy more instances. I can also see which services are available. So down here I've got my Redis and my Postgres instance. Again, we did all this from the command line. This is just a different way of doing the same thing, right? And the way you associate it, you can create as many services as you want on the bottom and then drag them into the center, and they get linked with the application. You create a binding. So I know that I have to delete this guy, right? I'm going to actually remove him. I'm going to remove this application, since that's the point. It's going to ask me if I want to unprovision all this stuff. I'm going to go ahead and leave it, actually. We'll hit finish. So I've deleted my application, but I've left the data services, including all that data that I put in there, in place. And then I'm going to drag my little new imported project, Spring project, onto here, and it's going to ask me, again, same kind of choices, right? I'm going to say, okay, Spring MVC 3.1, that's my new URL. Do I want to run it? Of course I do, sure. Do I want to bind it to something? You bet. I've got two services, one piece of information. And then I go in here and I say, delete from customer where ID equals 2. There you go. Now I bring up the same data. It's cached, so of course it's going to come up again, right? If I go in here and delete from 3, and now bring up here over here, you can see it doesn't come up because I didn't bring it up already. It wasn't cached. So we'll look at the caching in a bit. But basically that's the tour of how do I get my application, my existing Spring application with some interesting functionality going from both command line and from the Eclipse environment, right? Pretty natural. We've talked about the manifests. Let's actually talk about the real deals now. Cloud Foundry itself, like I said, runs on multiple clouds. So we've already seen that it runs locally. We've seen that it runs in your private PaaS. If you want to take the code and install it in your own data center, you can, right? If you want to run it in cloudfoundry.com, again, it's free during beta. You can get an account, and you can play with it there. The beauty of this project, the beauty of Cloud Foundry, is that it avoids lock-in. If you use some of those other clouds, not going to name names, but welcome, Google Engine. You'll see that they're going to try and trap you, right? They're going to make you build to their APIs, and you can't take your application away from them. So this is you guys know this one Eagle song? I think everybody knows it. Hotel California. You can check in, but you can never leave. That's what we're trying to avoid. We don't want lock-in, right? We want to be able to take our applications and move them as befits our use cases. Oh, that's ugly. But anyway, so this is a good example of the the entrapment scenario. In April 8th, 2008, somebody created a pull request. Somebody created a ticket on Google App Engine for support for PHP, that language I was talking about that nobody uses. And a lot of people said, I would love this. 3,000 people, 3,100 people even, said I would pay money for PHP support on Google App Engine. I would pay lots of money that costs money. I would pay good money for PHP support. And 3,000 people chimed in over the years, for years. And eventually in January of last year, 2011, somebody from Google basically came to the ticket and said, shut up! And he just muted everybody and closed the ticket. No support at all. Well, that's not cool. And I think that's bad. It's bad enough. But look at what they've done in the meantime as well, right? So in 2008, they just deployed Python. Okay, I'm a fan, whatever, good. Then they deployed a kind of a mutated bastard version of Java that doesn't quite work, but it's still Java-ish. But then they deployed Go. Are you guys doing Go? Is there a big craze that's going on where all you guys are going home and programming in Go? Do most of you, does anybody even know Go? Yeah, me either, right? So So that's their priorities. They're going to do what they want to do, and that's their thing, you know. With an open source project like Cloud Foundry, you have a choice. You have the ability to plug in the pieces that are important. So within weeks of our releasing Cloud Foundry last year, in April, we open sourced the code, and then within weeks of doing that, somebody created a pull request with code to support PHP. It took weeks, 2 weeks, to get a real functioning cloud provider that supports PHP. And as I've already mentioned, there's a company now called AppFog that has PHP support. And that support is built on this pull request. They're already making money. They'll already support your applications, and you can pay them money, and they'll support it, and they'll indemnify it, and all that stuff, right? So that's the difference. That's a big, big part of it. That's what I want when I build my Spring applications, right? Open source. I mentioned AppFog. There are other people. There's Node.js being supported by Joyent. ActiveState has a Python and Perl cloud called Staccato, right? Getting Cloud Foundry installed on your own data center, in your own firewall, behind your firewall. Because remember, a lot of us have two different use cases. People talk about hosted clouds, right? They can't go to cloudfoundry.com. So we have a lot of different ways to do it. There's a project called Bosch. We just announced it all of like 4 days ago, 5 days ago. And Bosch is a full-on, it's everything. It shows you how to deploy Cloud Foundry from top to bottom in your data center, or on Amazon Web Services, or on top of vSphere, you know? So whatever you want. I mean, it's very easy. There are Chef, ops code scripts, cookbooks for installing Cloud Foundry locally. And there's also an Ubuntu package. So if you're using Ubuntu, you just do sudo apt-get, I forget the incantation, but you do sudo apt-get something, and you get Cloud Foundry installed locally. And of course, there's my friendly, reliable, trustworthy, Wi-Fi proof micro Cloud Foundry. This is for developers, not for operations, right? You want to develop quickly. You want an environment that exactly replicates what you have in production. So you grab the micro Cloud Foundry, download it from cloudfoundry.com. It's free, and then run it. And it has everything you need. So if you're on a plane, on a train, on a boat, at a conference giving a talk, it'll work. This is a big deal, right? Services, and this is the most important part to me. This is where we started, right? Cloud Foundry itself supports many different types of services. We have out of the box MySQL, Redis, MongoDB, RabbitMQ, and Postgres. So if you need those services in your application, it's very easy to get them set up like we saw. I think there's kind of a market. I mean, this is just, if you guys make $1 million off my idea here, you guys are, I would appreciate some love. I'm not saying you're gonna, but my idea is we need COBOL. And now hear me out. I know what you're thinking. Who in the hell would want to use COBOL? But it turns out there's actually a lot of people with COBOL applications. And so if you could provide an easy way to talk to Kix from the cloud, COBOL in the cloud, I think that'd be awesome. And I mentioned this, by the way, at another conference about, 2 weeks ago. And some guy raised his hand and said, Josh, the .NET support, the Tier 3 support that we have, that partner that's also supporting Cloud Foundry, they can run what's called Iron COBOL on top of .NET. So it's actually already doable, and this slide is kind of wrong. But if you guys, I don't know. I just think that's ridiculous. There's actually already support for COBOL on the cloud. Not that you guys are going to do it, I'm just saying, but it's the nice that you can, right? You have the flexibility. The reason services are important is because they are what you need, right? They're the place where you store data. They're the way you build your application, the way you architect. And if you want to take advantage of these new technologies and new services, it can be painful to have to set up all this stuff locally, right? From a developer perspective, it would be nice if I could just experiment. Just set up RabbitMQ. I want to work with a message broker. I want to learn how to get started very quickly. I don't want to have to spend time compiling it on Windows and all that stuff, Same thing for Redis, same thing for MongoDB. It is also convenient that these different services happen to work very nicely with various Spring projects. So for example, if you need to work with NoSQL technologies, we have a project called Spring Data. Spring Data makes it very easy to work with MongoDB, to work with Redis, etc. We have, of course, great support for RabbitMQ and AMQP, the protocol that RabbitMQ uses for messaging, inside of the Spring AMQP project and the Spring integration project. And then, of course, we have, in Spring Core, we have transaction support, right? So you can work with JPA, JDBC, whatever you want, right? I also think we should take particular note of messaging. RabbitMQ is I used to say it was the original cloud messaging store, or the original cloud messaging service, But then somebody pointed this out, which is that he had thought of cloud messaging first. So it's the second cloud messaging thing. If you look at Cloud Foundry and Amazon Web Services, and all these other clouds, it's the #1 most used message queue for scaling and linking applications in a loosely coupled fashion, right? Even though Amazon has a proprietary API that they provide, people use RabbitMQ more, and we have it for free inside of Cloud Foundry. Now, having said all that, that's the kind of brochure, right? We all get what Cloud Foundry is. Let's talk about the 80% case, right? The 80% case is I've got an application. It's going to talk to a database. It's got Spring, maybe, or Grails, or one of these other technologies, and I want to get it in the cloud. I just want to get it moving. Turns out that's actually pretty easy. If you have an application it's already got a data source, and the data source is pointing to a local host or some other IP that's in your network, and it's already doing things with that, you can take that same application, unchanged, and deploy it to Cloud Foundry. And what happens is that data source definition, or that Redis definition, or that RabbitMQ definition, or that Mongo definition, all those beans get rewritten for you. So they're automatically going to be rewritten to talk to the correct port, to the correct host, to the correct IP in the cloud. So when you deploy, same code exactly. You don't have to do anything, right? The way this works is we install what's called a Bean Factory post-processor, for those of you who want the specific nitty-gritty. And the Bean Factory post-processor lets you override definitions of beans inside of Spring. You guys can create your own Bean Factory post-processors. It's the same class that we use to provide AspectJ support and to use property placeholder resolution and all that stuff. It's not something that's proprietary or anything to Cloud Foundry. If you want more specific control, if you want to map to a data source in your cloud to a reference that you have in your Spring application, or a Redis instance, or a RabbitMQ instance that you have in your Spring configuration, and you want to specifically say that this is mapped or bound to the service in the cloud, we have a namespace that you can use. So the cloud namespace, it's just a regular namespace. You import it into your Spring applications. It provides you with lots of different features, right? So here I'm using cloud:data source, and I'm saying I want you to map, I want a reference to a javax.sql.data source, and I want to use that in my local container entity manager factory. And this is going to pull down the data source that's provided by the cloud, right? So by Cloud Foundry. It's going to automatically create it for you. You don't have to know the host or the port or anything. It'll just pull it down. You can also specify details about, for example, the connection pools. You can specify, you can override there. And there's similar things for other different types of things, so MongoDB and so on. We also have the ability, if you're using Spring 3.1, to expose property values. Or if you're using Spring, before 3.1, you don't want to use it from XML, we have the ability to let you access property values about your environment from your Spring application, right? So here I'm getting access to the property for my MySQL data source, and I want to get access to the username. The reason I would do this is because I want to override the user. I want to be able to override which kind of data source I have. Here I'm going to create a combo pooled data source instead of a regular Commons DBCP data source, right? Finally, when you get into your application and you want to access information about what's provisioned and what's available, because it's a polyglot PaaS, it's a platform as a service, we provide environment variables. Now, don't freak out. I'm with you on this. Don't worry. The environment variables are there for those other people using PHP or special children. I don't know. But for us, more civilized Java types, there's a dependency you can add, right? It's a Java API that you can work with that actually gives you it gives you the ability to ask the same questions as you would with those environment variables. So if you don't want to pull down your environment variables and parse it and all that stuff, use this jar. Here's what it looks like, right, from your code. You can say cloud environment, give me a cloud environment. Then you can say, I want information about all my RDBMSs, my relational databases. I can do the same thing for Mongo and for Redis and so on, right? And then you can create a service creator implementation. Again, there's going to be a service creator that's appropriate to the type of technology you're looking to connect to. So if it's a RabbitMQ or a Mongo, it's going to be different. Because we support both Postgres and MySQL, this RDBMS service info will give you information about both Postgres and MySQL connections. And then from there, I can actually create a data source. I can use the data source creator to create a data source reference that I can use in my code. So this is not Spring, this is just regular Java, but you can also use it from Java configuration inside of Spring. Now, taking this back a little bit, let's look at an example that. Sorry?
The previous slide, the code you showed.
That was good code, wasn't it? I understand. Here.
Where is this code going to be used?
It's that dependency right here. This is a Maven artifact. Oh.
Why want to write those lines of code?
If you want to get access to the data, because again, the cloud hosts your data source. So the port and the IP and all that stuff, you don't know what it is. It's not like you can hard code that in a property file. So you need some way of getting access to the information and dynamically inflating or creating the references that you need at runtime, right?
I would have expected that to be done during deployment.
So this is at runtime if you need to do anything dynamically.
Right.
Get some DB details and file a query or do some business logic.
So to be clear, remember the 80% case area I was talking about? By default, if you have just one javax.sql.data source in your code and one, MySQL or Postgres in the cloud, it'll automatically map it for you and you don't have to do any of this. If, however, you have two, or if you want to be specific, then it can be very helpful to be able to ask questions about the environment. So here I'm going to pull down information from the environment. Now, let's take a look at a different example here, guys. I have, so this is another demo. It's again, you can get this one from github.com/Cloud Foundry, /Springsource /Cloud Foundry -samples. I'm going to go ahead and install this thing. Or am I? Come on. I really must learn to just not build stuff on demos. I know. It's just I'm compelled to try and prove that it's brand new and it's not like a thing, but sometimes I get shot in the foot. Yeah, I'm using 3.12 Spring, right? The new snapshots of the latest and greatest Spring because I'm a glutton for punishment. Okay, I'm sorry, but it's almost done. Wait for it. Come on. Could just try the other thing. Mother of God, that was painful. Okay, good. So, VMC push. I'm going to do -- path. And I'm going to do target. And I'm going to do cross store. Customer service.war. Customer survey, sorry. And I'm going to do push, right? So same thing as I did before. I'm going to deploy this application in my cloud. And this application uses Spring data, right? It's actually kind of an interesting application in of itself. It uses MongoDB and JPA. So use JPA for the transactional line of business, RDBMS type data, and then use MongoDB for the long tail data, the big data that scales out to zillions of records, sort of. So if I go to my command line again, I go VMC apps. You can see the application is running here on customersurvey.joshlong.micro, HTTP, right? And this brings up this little page here. And the application itself is very simple. All it's going to do is it's going to give me a list of JPA entities for customer data, right? I'm going to add a new customer. My name is Josh Long. I'm going to go ahead and view my customer. I'm going to add data, favorite conference ever. Yeah. Absolutely, right? And if I look at the information, I go back over here, go to home, I can look at the data being stored. Part of it is in MongoDB. It's stored as JSON data. That's the Q&A. That's the questions and answers. So if I have 1 million questions and answers, they get stored in MongoDB. But then the customer data itself gets stored in, I think it's MySQL in this case, right? Now, what's interesting about this is if I go back to if I go back to here, and I hit refresh, double click on this guy, come on. Okay. Go over here on the right, hit refresh. So you can see I've got my application, customer survey. Now on the right here, you can see I've provisioned one application. It's got 512 megs of RAM, and in the bottom you can see the port that this application is being served off of, right? So I'm accessing it via the cloud environment object that we just talked about. I can go over here now and upgrade it, and then you can scroll down, and you can see at the bottom here that I've got 2 different instances of the same application being started up for me, right? So there's one down there. You also can see the same thing if you go to VMC Apps and then ask it. It says 2. There's 2 right here, 2 instances of the same thing. So now I go back to my application, and I hit refresh, and come on. Waiting for this thing to pick up. Well, or not. Anyway, the application will, VMC status, let's just find out. Yep, there's a default load balancer that comes in the application, VMC apps. And the point is it automatically load balances the applications across the instances that are deployed. Okay, interesting. So the applications that get, so if there's state, or if you get like put on Oprah, you know, I don't know what's going to happen, but if Oprah talks about your application on TV one day and you need to add more instances, it's very easy to just go ahead and scale it out, and the instances themselves get scaled across the same URL, right? Actually, here, status. Well, I'm not sure what's going on now. Oh, my Wi-Fi just went out. See, you need that. My internet just went gone. Okay. Well, anyway. Point is, you can very easily scale it out. That's my point. Even from the command line, right? It becomes very easy to scale your application up and out. This is very powerful for the situation where you have a lot of state. A lot of people ask, okay, if I have state in my application, like session state, what happens? If you have the same session, it gets routed to the same node, right? But the session state is not replicated, so it's better not to rely on it. Okay, let's see. Running out of time. There we are. Okay, guys. Thank you very much. I will take questions, but thank you very much for coming. If you have questions, please feel free to reach out to me afterwards. Thank you.